Good evening to all of you.
Good evening, sir.
How are you all?
Fine, sir. Fine.
Nice.
What about you, sir?
All well. Still, everything is going fine. Yes, Asutosh.
Yes, sir.
So, how was your day today?
It was bit hectic, sir, because currently audit is going on.
Which audit?
Internal mass audit, sir.
Okay, good. So, it's a leading indicator, correct? So, doing your
Yes, sir. Yes, sir. And sir,
internal.
surprisingly, Mr. Ganesh Patil, he is here.
Okay,
He
very
told me
nice.
about you, sir.
Okay. He recently joined, I think, right?
Yeah, sir. Yeah, March, mid
Hmm.
March.
Yes, yes. Okay. So, this world is very small now, especially the
Of
power
course, sir.
world.
Exactly, sir.
Yes, yes. Okay, yes, Pradeep, Krishna. Pradeep, are you there? Pawan, good evening. Bala, Gautam,
Good evening, sir.
good evening.
Sir, good evening, sir.
Good evening. Saroj, Prashant, Ali Hussain,
Good evening, sir.
good evening to all of you.
Good evening,
Arin,
everyone. Good evening, sir.
good evening. Arindam, Mandal, Imran,
Hello, good evening.
good evening, Imran. Kashif,
Good evening, sir.
Kashif, good evening. Maruf Sheikh, good evening to all of you. Very less people have joined today. Why? Yes, Ali, good evening.
Yeah, good evening, sir.
What's going on there? All okay?
Today I was very busy actually.
Mhm.
That's why I
Very
cannot
nice. Nice
read
to,
very.
but nice to hear that you are busy. That means we are contributing something. Correct?
Yes, sir.
Hmm. Okay. Yes, Maruf. Good evening. Okay, Pawan. Good evening, Pawan ji. Are you there? Hello, Pawan. You're on mute. Yes, please tell how was the day for you. Hello, Pawan ji. Good evening. Gautam,
Yes, sir. Good evening,
how are
sir.
you, man?
Yeah, I'm good, sir. What about you?
I'm also fine. Okay, I think most of the people have joined. So, anything you want to discuss? Anything not from your syllabus? Some any other topic? Anything you want to share with your your colleagues? Anything which comes in your mind, which may be beneficial for all of them?
Sir, today is my first class. Basically, I cannot got the link last 2 days. Suddenly they forget to add me in the group. So today they add me. So today
Okay,
is my first class.
okay. So, can you tell me something about yourself in brief, Kashif?
Okay, sir. My name is Kashif Jave, sir. I have done masters in petroleum,
Okay,
and I have 11 years experience in the HSC. I was working working as a HSC manager in Saudi Aramco.
Okay.
I was working in Saudi Arabia since 11 years.
Okay. And basically, you are from?
And regarding the certification, I have done. I I'm from Pakistan, Karachi, Pakistan.
Your voice is cracking. We can't hear you clearly.
Basically, I live in the refinery area, so there is some signal error
Okay.
here.
And basically, you are
So
from?
due to
Uh-huh.
basically, I'm from Karachi, Pakistan.
Okay. Pakistan. Good. So welcome, Kasif, for this class. And I
Yeah.
think you have missed 2 or 3 classes. So in that, we have completed element 1 of the PSM courses. Okay. So I will advise you to go to the recordings of that classes that will be there in the Google Classroom. So that will going to help you. And if anything
Okay.
comes in your mind, please be in touch. I think you must be added in the WhatsApp group. So if you have any issue, any confusion, ask in the WhatsApp group, and we will try to answer your queries. Okay.
Okay,
So don't
no
worry.
problem.
Okay. Okay. So I think it's good to start. Now it's almost 10 minutes. We have passed.
One question.
Yes, please. I like questions.
Regarding this is about the examination. Regarding as Mr. I think Javed, he is on the duty. As similarly, some other colleagues will be also sometime on the duty. So while if they are on the duty and that's the day of the exam day, so as you told us that it is mandatory that you have to install some particular software on your machine that then you will be able to attend that session, examination session. So, for
Yes.
example, in that day, you don't have the access to his own computer. Can you access to the mobile or something else? Because you know the company on the company devices you cannot install the third-party softwares.
No, it can be installed if you take permission from your IT department. So it can be installed. It's nothing serious sort of software. It's a small app. So if you have any issue, please talk to your IT department of your company. And I think you must.
Usually the company policy is forbidden to install the third-party software because they
Yes.
don't.
So first, tell me, have you told your company that you're pursuing this course, PSM course?
Depends.
Have you-
Depends. Maybe somebody wants to reveal that
No,
they
no.
are doing
I'm
this,
asking you.
and sometimes
Have you told your company that you're pursuing this course?
if you are talking about my case, I have not
Yes,
told
yes.
about that.
I'm talking about yourself.
I'm not talking about that.
Not that. Okay, so don't worry. You can install that software in your personal computer, personal laptop, 1 week before also. Don't worry about that. It is a small software, Proctorio. So you have to check the compatibility of your laptop or your phone. But I don't advise to use your phone for the examination. Okay. Always use laptop or desktop.
So in any case, if I cannot access my computer, so we can access through the mobile as well, or it is
Yes, you
mandatory that
can.
you have to.
You can access with your mobile, but again, you have to tell well in advance to your course coordinator that you might use your mobile phone. Okay, so just tell them, declare them.
Okay, that's perfect. Because in any case, for example, we will try
Yeah, I
to do
understand.
on our
In case of
machine, but
yes,
when in
yes,
any case, for example, if you had to do, so we can use our mobile because
yes, yes.
company's policies sometimes you need further approvals and it is hectic. So to avoid the hectic, you can use your mobile. So this is we can do, so it is better.
Yeah, yeah, sure. Just whatever you want to do, please be in touch with your course coordinator. They will convey this message to Nibosh. Okay.
Sure. Thank you so much for it.
Okay. So now it's good to start.
Yes, good. Please.
Okay. So hope my screen is visible to all of you.
Yes, sir.
Visible.
Okay. So yesterday we started with element 1.6 or 5, sorry. No, 1.6. We started 1.6. This we have done on the first day, correct? So we have started element 1, which talks about the competency. So we talk about the competency. What do you mean by competency? So always remember, competency is the liability to undertake responsibility and to perform activities to a recognized standard on a regular basis. Means consistency is required. That's the main criteria of competency. Apart from skill, experience, knowledge, and other things, qualification and your degree or whatever you say, certification. Consistency is the main part of competency. So why we require competence in process safety and what gain we can have with a competent person at our site in the process safety. So yesterday we have discussed 3-4 examples of operator or your maybe your engineer or your maintenance part. Everything we have discussed yesterday. Then what are the benefits of the training? And this is for all, not only for workers, okay? And as you know, as per the definition of ILO, whoever works in the company is a worker. Either it's your MD, CEO, CMD, or a simple housekeeping labor. All who are working in a plant is a worker. So this training benefits is for all workers, including your higher management to the staff working in the ground. Then what type of training need analysis to be developed for different type of people? Yesterday we have seen and we have brainstormed that. So this checklist has to be developed for the development of a person and to enhance the process safety of the organization. Then who needs this training? Already we have discussed. And that's it for the element 1. And after that, we have done some quiz. 4 or 5 questions were there. And after that, we have started element 2. So in that element, now we are going to establish the process safety management. So for that, what we required, PDCA cycle. Hope everybody remember this PDCA cycle. I have given you a simple example of our day-to-day life. So all things comes under PDCA cycle. Either it's your health and safety management, your own personal management, or anything. This cycle is always running. Hope everybody remember this PDCA cycle and the examples. Correct? If someone has any issues, any confusion, please ask me. What is PDCA cycle? Anyone, please? Have you got any confusion, anything to discuss on PDCA cycle? Because this is very important. Anyone has any questions on that?
Oh, last year you explained in very common examples. It was loud and clear.
Okay. So after that, we talk about license to operate, why we require license to operate, and in Europe and other countries, what we require. As per the UK Control of Major Accident Hazard Regulation, COMS 2015, we need to present a MAPP, that is called Major Accident Prevention Policy. In that policy, what we require. So these are the things we require. Before getting the CTO consent to operate, we have to submit this document MAPP, which has these things in the content, minimum things. This is not limited to this, but these are the minimum things we have to give in writing to the agencies for getting the CTO consent to operate for any process plant. Then we talk about the leading indicators and lagging indicators of the process safety. As we have leading and lagging indicator in the general safety. Process safety also have leading and lagging indicator. So with examples we have discussed yesterday. And when both this leading and lagging indicators combines, is also give a fruitful information to the management about the process safety. And based on these two leading and lagging indicators, we can implement so many action plans, corrective measures based on the requirement. So one case study of road safety. Then what are methods of developing the process safety indicators? Why we do auditing? What do you mean by audit? So audit is always based on examining evidence. Remember, sometimes question comes. Now, after that, we started the risk management techniques, different types of risk management. Again, I'm reiterating that this is only for your reference. We don't have to go deep inside the different techniques, but you should remember the names and what are the proactive and what are the reactive sort of risk management techniques. In the question, it will come. So we have started with what are the risks and hazards, how to do the risk assessment. So there are 5 steps. First, we have to identify the hazards, and second step, who and how. That is very important. Only people identify who, but they do not identify how they can be harmed. So it's clearly written who might be harmed and how. Look at this word, who and how. How is also very important when you developing any risk assessment. Then after that, we have to evaluate the risk and decide on the precautions or the action items or what additional precaution you have to take to mitigate the risk and hazards. And step 4, we have to record the significant findings. And last step is to review your risk assessment and update it as per the requirement. So different companies have different frequency of updating their documents. Some companies do it in quarterly, some they do it biannual, some do annually, some do twice every second year, and some company do in every 3 years. But there are some conditions in which you have to review your risk assessment, like any major accident happened, any major person changes, any material, any process changes, any legal requirements are there, any audit investigation report says that you have to review your risk assessment sort of thing. So that we will cover later, but minimum there must be certain frequency or certain timeline to review your risk assessment as per the company policy. We also talk about risk matrix, then type of risk assessment. So qualitative, semi-quantitative, and quantified risk assessment. In qualitative, it's just based on personal experience. It depends on a person, their experience and their knowledge. So they can decide which risk is high, low, or medium. And in semi-quantitative, we have to give some digits or some calculation to arrive at the risk rating, which is low, which is medium or high. And in quantified risk assessment, this is mainly used for high precision or very high risk industries like space programs, underground tunnels, undersea railway projects, or some high risk, very, very high risk activities where all data are known to us, and each step is again minutely break out into sub steps, and for that sub steps we have to do the risk assessment, and accordingly we have to identify the control measures. Each and every step they have to break up into minutely, or you can say it's a micro arrangement of risk assessment. In semi-quantitative, it's sort of a macro. But many industry, almost every process industry, do this semi-quantitative risk assessment. And some organization use 5x5 matrix, some use 9x9, some use 11x11, 13x13, based on their hazards and risk at their premises. Then we started one risk assessment technique that is called Swiss cheese model. So as the name suggests, cheese. So these cheese layers are our control measures. And you know, this every cheese layers have some holes in it. So when any risk or hazard passes through the layers, they can start by second layer or third layer or fourth layer or maybe fifth layer. But sometime it happens that all holes are aligned and accident can take place. That means all your actions, all your control measure fail and accident happened. So this is well described by this cheese model. That's why it is called Swiss cheese model. One example we have seen like this in the COVID period, you can say what are the different control measures. We have to distance from other people. We have to use mask. We have to clean your hands. Cleanliness, hygiene you have to maintain, and hand washing. Suppose all these things are adopted by a family, but it happens or it can be possible that this COVID can affect this family when all these holes are aligned and they can be affected. So this is called a Swiss cheese model of risk assessment. Okay, so up to here we have covered yesterday. So any questions from anyone in this? Any questions, please?
Thank you. No question from my side.
Okay. So now we will go through the second techniques of risk tools, that is bow tie model. Now, in this model, we have to do the risk assessment with the event, what are the threat and what are the consequences. And in the threat, what are the causes, what are the, and in the event, what are the hazards, and in the consequences, what are the effects. So it's a team model, teamwork, and it has to be done with help of a competent team or competent group of people. The name bow tie comes from its shape. If you see the shape, it's a sort of bow tie. So what is bow tie? Do you know bow tie? Anyone know what is bow tie? We are using long necktie, right? You wear neckties along with shirts and coats, right? You wear ties, simple tie. Hello. Am I audible to all of you?
Yes, you can. We can hear.
Yeah. So we wear long tie, right? Long necktie, correct? But if you go to any restaurant or bar or any hotel, they used to all waiters or other people used to wear a small tie in his neck. Have you noticed it? Small tie, just covering the collar. Small tie.
Yes, sir.
That tie is called bow tie. So the shape of this risk assessment, it's similar to the shape of that bow tie. That's why it is named bow tie model. So it's a bow tie method is a risk evaluation method that can be used to analyze and demonstrate causal relationship in high risk scenario. The method takes its name from the shape of the diagram that you create, which looks like a men's bow tie. Why? Look at this. When we do the hazard analysis or risk assessment, final outcome is looks like this. In the center, it's a hazard. In the left side, it's your threats and what prevention you have. Event happen, that means hazard is there. So what are the mitigations are there, and in the recovery, and what in the consequence, what happens, what are the potential outcomes. So each and every hazards are analyzed based on this model, and shape comes like this. So this is called bow tie model of risk assessment. Okay. Now, one very disastrous accident in industry, mainly in the modern industry, is a Bhopal gas tragedy. It happens on December 2nd, 1984 in Bhopal in India, where a very hazardous chemical, methyl isocyanate, MIC, which was spilled out from Union Carbide's company, it's a pesticide company, into a colossal gas chamber, and it was India's major first industrial disaster, major disaster. So what went wrong in that? That gas, the highly toxic methyl isocyanate gas, can cause death within minutes of inhalation if its concentration exceeds 21 ppm parts per million. That was the reason for so many deaths and the crippling after effect on hundreds of thousands of survivors for decades, as per organization. Still now, after 42 years, still that place is not normal. What happened there? Release of methyl isocyanate gas from the MIC tank. When it happened? At the time when the water mixed with methyl isocyanate. How it happens? They have not maintained the safety system. One example, they have not maintained the reading of the pressure gauge. Why this happened? Because there is no inadequate planned maintenance. And what are the potential outcome of that incident? Loss of plant, workers, and nearby peoples. Before the incident, if you go through that Bhopal gas tragedy documentary or in the YouTube, you will find that management has not invested in safety. They have not done the maintenance as per the schedule. Some equipments got damaged, but they have not changed it on time. Like the water cooler system, there is a water cooling system was there. They have replaced, they have used in some other plant, but they have not installed the new system in the plant. Some drain valves are not working. So very simple things were there. Management had not taken interest on time, and this incident happened. Why? Just to cost cutting. They want to make more profit, and due to that, this incident happens. So I request all of you to please go through the documentary of this, which is in the Google Classroom. You can find it also in the YouTube. Okay. Now, third type of technique of risk assessment is HAZOP study. And this is very famous in all process industry. I think some of you might have gone through this HAZOP study of your plant. Has anyone go through this HAZOP study? Anyone? Do you know what is HAZOP study?
Yes, I know. In our organization, this type of hazards and vulnerability study already conducted.
Yeah, already conducted. This have been done by third party, correct?
Correct.
Yeah. So this HAZOP study, the full form of HAZOP is Hazard and Operability Study. Okay. Now there are 4 steps of HAZOP study. First, you have to make a team from all departments. Then the second step, you have to identify the element of the system. What are the different elements? Then in the third step, consider variation in operating parameters. And in the fourth step, you have to identify any hazards or failure points. Okay. And this HAZOP study was first used by Imperial Chemical Industries, ICI, in 1960. Some questions has come in past when the first HAZOP study was conducted. They will give you some 4 options, 1960, 1975, like that. So you have to remember 1960s. And sometimes they ask from where this HAZOP study was first conducted. So it's Imperial Chemical Industries. So what does HAZOP study is? It's a very thorough analysis of a process to identify ways in which the process could deviate from a design intention in order that controls can be developed. And different ways we have to identify how it can fail. Okay, and it is usually chaired by an independent HAZOP leader and involves a multidisciplinary team of designer, engineer, safety professional, operators in the area, and other specialists. As I told you, it's a teamwork. All people should be there who are associated with the risk and hazard. Either it's the operator or the shift in charge or the designer, safety person, shift manager, all should be involved in that group. Now, how it is done? This HAZOP study is a bottom-up technique. Now, what do you mean by bottom-up technique? What do you understand by bottom-up?
Same like pyramid rather than
What the name suggests? Bottom-up technique. Maybe that was similar, but why it is called bottom-up?
maybe to identify the cause of event, final top-down event.
Bottom maybe is talking about the from the basic or from the start, something like this, from the bottom.
We are very near, not basic, but all the suggestions and hazard and risk come from the ground level. As you see in the previous slide, it talks about what? Operators, right? So that's why it is called bottom up. Means all this risk and hazard comes from the ground. So it escalated towards up. That's why it is called bottom up. And top down, what happens? It comes from management, top management. It distributed to the down bottom. That's what is called bottom down. And it is called bottom up. So remember, sometimes questions comes. HAZOP study is which type of technique? Bottom up or top down or some other they will try. So this is a bottom up technique which use prompt about what could cause the process to lose control or to deviate from the design intent. And this HAZOP is done with the help of piping and instrumentation diagram. Have you heard about the PNID diagrams in your plant?
Yes, it's very common.
Yeah. So if you see, this type of drawings will be there in your plant. This type of where your piping, where the pipe is going, which system is this, what instrument and other things are associated in this line. All things are detailed given. So this type of drawing are called process piping and instrumentation diagram. So what happened? Suppose water system, where water is coming, cooling water from where it is coming, where it is distributing, what type of gauges, flow meters are there in that system, where are the PRV and all the things. So all these things are mentioned in this PNID, piping and instrumentation diagram. Why it is called? It shows from where to where it is going, and instrumentation means what type of different gauges or different equipment of C&I measuring instruments are there in the pipeline. So that's why it is called PNID diagram, piping and instrumentation diagram. So this HAZOP study carried out with the help of PNID diagrams and break the process down from small sections known as nodes. And for each node, identify a parameter to be examined like flow, a series of guide words we use like no flow, less flow, more flow, and are agreed upfront and combined with each parameter to form a deviation. Okay. So how it is done and where it is applicable? So this HAZOP study is applicable for all type of project. Either it's a new project, greenfield project, brownfield project, running plant, construction plant, commissioning going on, any major deviation you have done, any major modification you have done, MOC you have applied, major MOC, and periodic review of your existing operation. In this phase also, it is applicable. And which industries we can cover through HAZOP? All type. Either it's a chemical industry, pharma industry, oil and gas, nuclear, your thermal, power sector, your medical industries. Every industry is covered, can be covered under HAZOP study. So this is applicable for all type of project and all type of industries. Now, as we discussed in the HAZOP study, we have to talk about the different parameters and against which we have got keywords and what is the definitions. Like a simple example of flow. So keywords can be more flow, no flow, less flow, or reverse flow. And based on that, what are definition? More means quantitative increase, no or less means quantitative decrease, reverse means opposite direction. Same with the pressure, temperature, and other things. Now how to do that? What are the different nodes? You can say first parameter is the temperature. So guide word may be more. And what is the division? More temperature. What causes the more temperature? More hot fluid of water is there. What the consequences from the more temperature? Scald can form in the system. And what action we have to take? We have to install thermostatic valve. What will be the second cause for more temperature? Your boiler is supplying too much high temperature. So again, it can have scald in the system. What are the action we have to take? Maintain trend operator for the boiler. Third division, what happened? What was the cause? Maybe for the high temperature, there is less flow of cold water. The quantity is not enough to cool the system. For that also, what is the consequence? Scald can form. And what action we can take? We have to investigate engineering solution and we can have extra supply of cold water to the system. Okay, so this is the case when temperature is more. Same for the temperature, it can be less. So what is the deviation? It's a less temperature. Again, what are the cause? More flow of cold, boiler too low, and less flow of hot or other tap used. So again, discomfort will be there in the system, and what are the actions we have to take. So this type of analysis of all type of deviation which can happen in the system, we have to do that. And for each and every parameter, we have to identify this type of deviations, what are the cause, what is the consequences, and action. So we have to break up all our process into different small segments. like for, as I told you, water system. So this hazard study can be done only for water system. Same can be done for lubrication system. Same can be done for the gas system where the gas is going, or the steam system where the steam is going. What are different type of gauges are there? What are the different type PRV are there in the system? So every systems we have to do the heads up study and have to find out what deviation can takes place for each and every parameters, and accordingly we have to find out the cause, we have to find the consequences, and we have to find out the action. Okay, so this is regarding heads up study. Now next, yes,
During the hazard, normally we also mention the controls, available controls, and if something is missing, then we
yes,
advise or suggest
what
the
is the
controls.
available control and what additional control we have to put in the system, correct?
Yes,
So
and also in the industrial practice is used for the low and high words rather than more or
yes,
less.
yes, so there are so many guide words for that, like this temperature is more. If for flow there is no high like that, keywords or the guide words. There is no flow, low flow, high flow like that. So depending on the parameters, different guide words are there, standard guide words, and accordingly we have to take the action. And as you told that existing control measures are already there in the PNID. Why we mention the PNID? If you see, this PNID has all the things in the system, like the temperature control. So what are the different type of water supply arrangement is there in the system? That is already there in the PNID. So if it is not controllable, then what additional control we have to make our system safe and our process safety should maintain. So this is called your hazard study. Next type of identification is called the tool for identifying hazard is simple, your hazard identification, hazard. So this hazard is what? It's a structured, again, it's a team-based approach to identify hazards, their potential consequence and requirement for risk reduction before changes are made to existing process and plant. And this hazard or hazard identification is a method for general hazard identification, normally carried out prior to HAZOP, right? And it is simply done at all plants. The simple risk assessment, right? General hazard identification, HIRA. So this is one technique of identifying the risk. Now comes another method. It is called FMEA, or failure mode effect analysis, and it's a proactive method. So please keep attention to the highlighted words, as I told you many times. Sometimes it asks what type of method it is, proactive, reactive sort of thing. What is bottom up and top down process. So HAZOP is bottom.
What is the difference? What is the difference between the FMEA and HAZOP? Because this HAZOP is also the kind of proactive.
Yes, it's also proactive, and this is also proactive, but the technique is different. Like in the HAZOP, there is a guide words, then deviation and other things, right? In the failure mode analysis, we just simply list out what type of failure can take place. There is no guide words and other things. We have to form a team from different users, and they can suggest what type of failure can take place in the system. Again, I give you example of water system. So if there is a water system, a team will be constituted from user department, maintenance department, electrical department, safety, and the subject specialist. They will brainstorm and they will come to a conclusion that this type of failure can take place in the system. There is no any guide words or something like that. And based on their listing, what may went wrong, we have to identify the control measures. So what they do, they gather in a room, and there is a board, or you can say a big notice board sort of thing, and in the sticker, small stickers, all will write their failure mode. What type of failure can take place? Left side they will stick the failure chances, and after completing all the failure things, they will write how to control it, how to mitigate it, and stick on the right side of the board. And when they complete, this should be analyzed and make a sample table, or you can say it can be documented. So this type of analysis is called failure mode effect analysis. There is no guide word, no standard deviations. The user and the subject expert has to find out what can went wrong.
Can you
That's
give
the
one
difference.
example? Can you give one example for the FMEA? Because which I can understand that it is almost similar to the HAZUP and also the FMEA.
Yes, it's a sort of similar, but HAZUP is what is standard thing. Sometimes what happens, this FMEA, in the FMEA, people can forget what went wrong. Chances are there, although it's not happened, but chances are there that they may forgot some failure. But in the HAZUP study, it's clearly mentioned, like in water, it can be in the water flow. Suppose there is no flow, what will happen? High flow, what will happen? No low flow, what will happen? So all scenarios are already mentioned in the HAZUP study. So there is no chances that anyone can miss on that. But in FMEA, there are chances that people can forget some of the failures. So that's why HAZUP study is more famous in the industry. Okay. So this FMEA is a systematic, proactive method for evaluating a process to identify where and how it might fail. So just see the difference, where and how it might fail, and to assess the relative impact of different failures in order to identify the part of the process that are most in need of change. So again, what we do in the process safety, sorry, FMEA, we have to make a team, as I told you, from all users and all stakeholders who are associated with risk and hazards. And like if you see failure of pressure vessel, some guide words, failure of flange weld, what will be the nature of the event? Leaking flange. What can be the cause? Maybe gasket failure. What will be the consequence? Loss of containment. What control of mitigating factors? Likely to be progressive if corrosion. What are the hazard index? High or low? Then what action required? Comment. Review the reliability of the fitted gasket in the flange. So in this way, they have to brainstorm. Second guide word may be failure of flange weld. So what will be the event? Leaking oil. What was the cause? Corrosion. What will be the consequence? Catastrophic failure leading to large leakage. Then what are the control mitigating? 6 monthly NDT PIG to be conducted. What is the hazard index, high or low? Then what is the action required? Review welding protocols and post welding NDT, non-destructive test. So in this way, we have to brainstorm the failures. So this is called failure mode event analysis. So this FMEA components of the system are failure modes, way in which the system can fail, what will be the effect, what is the severity, what are the causes, what are the occurrence, what are the detection modes, what detection we have to do, and in this we have to identify the RPN number, risk priority number. Sometimes question comes from this, what is RPN number? Okay, so remember this RPN number, risk priority number. It is a product of severity, occurrence, and detection. Only question comes, what do you mean by RPN number? Sometimes they ask the definition. So it's a risk priority number, and sometimes they ask about this formula. They will give you 3-4 formulas in the option. We have to identify which one is the correct one. So it's severity, occurrence, and detection. SOD. Just remember SOD. Severity, occurrence, and detection. And it also talks about the recommended actions. What action is recommended, by whom and by when, and accordingly, as per the RPN numbers, we have to prioritize it. So what is the RPN number? This is your RPN number. So this is calculated, as I told you, by multiplying severity, occurrence, and detection, SOD. Severity is the failure mode, as we have discussed in the 5x5 matrix also, but its scale ranges from 1 to 10 in this FMEA. All scale are from 1 to 10, either it's a severity, occurrence, or detection. Occurrence is what? The potential of failure of occurrence is rated in a scale again from 1 to 10. A high occurrence rank reflect high failure. And detection, how do you detect it? The capability of failure detection rank again from 1 to 10, and high detection rank reflect low detection capability. So this RPN number comes from multiplication of severity, occurrence, and detection, and always it is coming in higher numbers for higher risks. So based on the number, we have to prioritize from which to which range it is low, from which to which range it is medium, and from which to which RPN number it is high. And based on the RPN number, we have to prioritize our actions. Okay, so don't worry about the other things. Only remember what is RPN number, what is how it is calculated, what is the formula, and the scale. That's why it all are highlighted. So in RPN, scale is from 1 to 10. Sometimes they will ask in the question, the scale of RPN parameters are ranges from 1 to 5, 2 to 5, 2 to 6, 1 to 10, like that. So always choose 1 to 10. And what is the formula of calculating the RPN number? So it's a multiplication of severity, occurrence, and detection, SOD. RPN is equal to S severity multiplied by occurrence and multiplied by detection, SOD. Okay, so as I told you, you don't have to go in depth, only the main things in the risk detection or risk hazard identification systems. Now, this is the FMEA process. Assemble the team, list failure modes, rank the severity, list potential causes, rank likelihood, list process controls, rank detection, calculate the RPN, take action on high priority RPNs, and recalculate RPN. This way, this FMEA process works. One more type of risk assessment tool is your event tree analysis, ETA. Okay, so why this name comes? Again, it looks like a tree, branches of tree. when we populate it, it forms or give a shape of a tree. That's why it is known as event tree analysis. So again, this event tree are used to evaluate the mitigation measure that will operate after an event. So it's a reactive approach. It's not a proactive. It is not highlighted, but you have to make a note that it's a reactive approach. Why? Because we do the analysis after any incident happened. So this is a reactive approach. Okay. The process starts with the initiating event, the disaster which has already happened, and work forward in time to see what protective measure will operate. After this happened, what can be done to prevent it? And each control will either be success or a failure. So whatever control measure we applying, it can work or cannot work. It can be success or cannot be not be. So it's a success or a failure. In this way, branches are built up on the tree. So if you see, it is not there, but it looks like a branch of a tree. So it's called event tree analysis, and it's a reactive approach. So if you see, compare with the fault tree versus event tree, this fault tree is a proactive and it's a reactive. After reaction happens, we can do the ETA. But fault tree we can do proactively. This is a simple comparison between fault tree and event tree. Now in the event tree analysis, the initiating event is an event tree which usually fall into one of the following four categories: either failure or unsafe condition in individual item of equipment, it can be human error, it can be utility failure, or extreme event. Means we have to take the natural calamities also, like hurricane or earthquakes, in the event tree analysis. So you see this, when we populate it, it looks like this one. That's why it is called event tree analysis. Okay. Now, where we have to work. Suppose we have done the analysis and all risk and hazard we have identified. So we have to draw a line where people can allow to work. So you see, this is an inverted triangle, says the magnitude of risk and what are the costs for controlling the risk and how the risk is increasing as per the risk analysis. So if you see, the bottom triangle is green, where risk is low and cost of controlling is also low. So this is called tolerable limit. We can allow any work to happen in this region. Second, the middle one is called the alarm region. Alarm means as low as reasonably practicable. We have taken all the measures, all the control things. So the risk comes in this region, which allow work to happen. As low as reasonably practicable, a level of risk that is intolerable and cannot be reduced further without expenditure of cost disproportionate to the benefit gained or where the solution is impractical to implement. Means we have taken all the corrective measures, all the precautions in terms of cost also and in controlling the risk also. After that, if we try to mitigate it, either cost may increase or it is not benefited. So maximum we have to work in this level, alarm. So sometimes question also come, what do you mean by alarm? So it's simply to remember, as low as reasonably practicable. And when any risk or hazard comes in this region, that is intolerable. So intolerable levels of risk, adverse risk are intolerable. Whatever the benefit and risk mitigation measures are essential at any cost, effectivity is to continue. So in this region, cost is also increasing and risk is also increasing to mitigate. So whenever any risk or hazard comes in this region, you have to take your management into discussion that this is risk is coming in this region. So please advise what to do on that. But there are very few activities which comes in this level. Mostly all comes under ALAP region. That's why it is very important to bring all the work in ALAP level where cost and risk are balanced. Okay. Now, as we all know, and I think on the first day, we also talk about the inherent safety. What is inside your system, which is inherent. So the HSC commissioned an offshore safety report called Improving Inherent Safety, which described inherent safety is the fundamental approach to hazard management, which emphasized avoiding or eliminating the hazard at source rather than relying on add-on safety feature or management system and procedure to control them. And if the process industry, the need to have hazardous substance and worker in close proximity is often unavoidable, but the process can be made inherent safer by design, like segregating accommodation modules from production modules or by locating office building away from production area rather than relying on active safety system. So it talks about controlling it from the design stage, that your system will be safe from any inherent danger. But it is not 100% practical to design the system safe. Always there are some risk or hazard inherent in the system that we already discussed on the first day. Right? Now comes the hierarchy of control. So all we know, there are 5 hierarchy of control. The hierarchy is elimination, substitution, engineering control, administrative controls, and PPs. But most effective is the first one, elimination. And PP is called last line of defense, and it is least effective. So whenever we recommend any action, we have to follow this hierarchy of control. Always remember, whenever you develop any risk assessment, you have to follow this hierarchy of control. Now some examples. This is an example of elimination. This person is manually lifting, but we have eliminated the lifting of the person through some mechanical arrangement. Then substitution. Again, we have substituted this loading things with some mechanical moving device. This is substitution. Then in engineering control, there are a lot of things we can do. Isolation or total enclosure, separation or segregation, partial enclosure, safety devices, and many other more things we can do in the engineering controls. Also, in the administrative control, lot of things can be done. We can implement the safe system work. We can implement the PTW. We can reduce the exposure of the person. We can give training, instruction, information, and supervision during the work, job rotation, and other things. And lastly comes your PPs. So this PPs or equipment or clothing that is worn or held by a worker that protect them from one or more risks to their safety or health. And there are different type of PPEs for different part of the body, ear, eyes, hand, leg, head, sort of thing. But remember that this PPE should be as per the job specific. We can't use common PPEs for all work. Like for electrical system, we need different type of gloves, different type of tools. But and for chemical industry, we need different type of protective gears. For hazardous, some other hazardous area like the radiography test, we need different type of PPEs. For lifting, for carrying out the sharp object, we need different type of hand gloves, cut resistance hand gloves of cut resistance 5. So all your PPEs should be job specific. Okay. So any question till now from anyone? From where we started? We started with this bow tie, right? What is bow tie? What is HAZOP? What is hazard? What is FMEA? What is RPN number? What is ETA? Then ALARP, what is ALARP? What is hierarchy of control? So that we have discussed till now. So any question from anyone, please feel free to ask.
Thank you.
Okay. Any other thought from anyone, please? Do you want to discuss something? Anyone, please? Anything in your mind or want to discuss anything? No one? No questions?
No, sir.
Okay.
No, sir.
Okay. So we will do one more element today, that is called asset management and your maintenance strategies. So what do you mean by asset management? Any idea? What is called asset management? What do you mean by asset?
Equipment, machineries.
Okay. Anything else can be added in asset?
Property of company.
Huh?
Property of company.
Yes, property of the company. So anything inside your plant is your asset. Okay. Anything inside your plant is your asset. Correct? And what are the maintenance strategy? Do you know what is maintenance strategies? Different type of maintenance, you know, different type of maintenance we used to imply in our industry. Huh?
Preventive maintenance.
Okay. Then
Routine maintenance.
okay.
Downs.
Then breakdown, right? Breakdown. So
Yes.
mainly, so we will touch upon this type of things in this element. 2.3 talks about that. So what are the different integrity standards? What are some definition? So whenever specifying equipment, consideration should be given by design standards such as EN standards or process safety standards such as pipe pressure rating or welding standards like Pressure Equipment Safety Regulation Act 2016. This means that expert advice may be needed to ensure the correct decisions are made at the design stage. Now some definition: asset, an item or equipment or an area of production plant And this asset integrity is the ability of the equipment or asset to operate as intended effectively and efficiently over an entire lifespan while ensuring the health and safety of those exposed to it, including the environment. Means suppose a pump is there which has the capacity or the design for supplying 30 meter cube of fluid in an hour. So the asset integrity means it should supply 30 meter cube of fluid throughout its lifespan, means the efficiency. But also at the same time, it should ensure the health and safety to the person or to the operator who is operating it all the time. That is called your asset integrity. And double block and bleed, it is mainly used in our chemical industries, in our oil and gas industries. What does it mean? The process of isolating a chemical or process line by closing and locking or tagging two inline valves and opening a drain or vent line between them. This ensures that any leak are to a safe location and not the open end of the line where work is carried out. So I think our friends from oil and gas industry or from chemical industry, they should know what are the double block and bleed. Have you heard this term? Hello?
No, sir.
Yes.
Not heard? Okay. So what we do, suppose there is a chemical pipeline, okay, and your valve will start leaking, control valve will start leaking. Just an example. So you have to maintain the valve, correct? Yes or no?
Yes,
You
sir.
have maintenance work. But as this pipeline is handling a hazardous chemical, we have to make that area of work more safe. So what we do, we have two inlet valves and two outlet valves in that pipeline. It is designed. Okay. So when any maintenance work we have to give the PTW or the permit to work, we have to isolate both the inlet valves and both the outlet valves. And sometimes a blank is also done in the valves. So in any case, if there is any leakage in the valves, the person who is working in that area could not be exposed to the hazardous chemical. And also what we do, we drain the pipeline, we vent the pipeline, we flush the pipeline so that no any trace of chemical will be there in the working area. That is called double block and bleed system. Clear?
So please repeat again.
Okay. Suppose you are working in a oil and gas plant. Okay. One pipeline is there where oil is flowing, like diesel or petrol is flowing through that pipeline. Some leakage or some maintenance work has to be done in that pipeline. So what we do, there are two inlet valves and two outlet. I mean, two upstream side valve is there, two valve in the downstream side. So what we do, we close both upstream valves, both downstream valves, and we also blank that valve sometimes to double sure that there is no any leakage of oil from that valves, and it will not going to come in the system during the work, and our people are safe. Okay. as there is a diesel or petrol is flowing, there are chances that fumes will be there, and some oil and petrol will be there in the pipeline. So what we do, we drain it. Drain valves are also there, and vent valve is also there. So we first drain it, we vent it, and there are also chances that fumes of petrol or diesel will be there in the pipeline. So we flush it. We sometimes we use to give inert gas, N2, nitrogen purging, we do from the pipeline. So there is no any trace of oil or oil vapor will be there. So that type of system is called double block and bleed system. Clear?
Yes, sir. Is there any rule that to provide 2 inlet or 2 outlet valves on pipeline?
Yes, for hazardous material, hazardous substance, it is required. So, in which industry you are working?
In manufacturing.
Manufacturing. So maybe it's not required, but in the people working in oil and gas, they can comment on that. Any person from oil and gas, do you have this system in your pipelines?
Yes, sir.
Yes,
We
sir,
have
we
this
are.
system.
We have
Yes, you
system
have, na?
before we have starting purging.
Yes. So you follow this double block and bleed?
Yes, sir.
Yes, sir.
Okay, so that depend on industries where you are working.
Okay.
Okay. Now, for the whole asset integrity, there are 6 phases. First phase is your design, how you design your plant. Then second phase is your, as per the design, what to procure, what to construct, how to install, and testing. Then in phase 3 comes after installation, you have to commission it. And in the commissioning, what you do the functional test, and this has to be certified by third party. That, as I give an example, a pump has to deliver 30 meter cube. So after commissioning, third party will check that this pump is delivering 30 meter cube of the fluid, and they will certify it that this is okay. Pump is giving the flow of 30 meter cube as designed. So after commissioning, fourth stage, what? We hand over this equipment to the operation and maintenance department. In the fifth stage, if maintenance or operation suggests some modification, some MOC, they will carry it out in that system and make sure that whenever they do any modification, all our risk and hazards come into the alarm prison. Means as low as reasonably practical. And the final phase is the decommissioning. Means when your plant or equipment has served its life and it has to be decommissioned. Okay, so these are the 6 phases.
But I think this life asset integrity will be vary for each industry, I believe so.
Yes. Every industry, but this is the 6 phases. Every plant has these 6 phases. So some plant may be decommissioned after 25 years. Some can be after
But
30 years.
in our projects we are following is called phaser studies.
Yeah.
Which consists of 8 phases on this.
Okay.
7 or 7, sometimes 8, depends on the handover and methodology procedures.
Yes, what your organization adopted. But mainly these 6 phases are there for the asset integrity. Okay. Now, whatever maintenance we do, we have to maintain the documentation. And this maintenance record will be need to retain carefully. Some of these are retained required locally, but some, for example, the statutory required of pressure system, Legionella control, LEV testing, lifting equipment may be legally required. All lifting tools and trackers, they require third-party verification and certification. And record can be paper or electronic, but must be traceable. Now comes different type of maintenance strategy. So first type of strategy is maintenance breakdown maintenance. So what happens? Suppose some equipment is running, and due to some mechanical or electrical failure, it is not operating. So what we have to do? We have to do the breakdown maintenance, because that system is now under breakdown. It is not operating. So what we have to do? Operator repairing or replacing plant or equipment that has failed while in use. And it was running, but it had some issues on that, maybe mechanical, maybe electrical, and it is now not operating. So that type of maintenance is called breakdown maintenance. Second type of maintenance is called condition monitoring. Suppose, again I give an example of some motor or pump. It is running, but suddenly its vibration increases. When you measure the vibration, it has increases. Or some abnormal sound is coming out from that. Or you have done the thermography, you see that bearing temperature is high. So this gives some indication that something can fail if we continuously run this motor or pump. So what we do? We stop that pump and maintain it. We change the parts and we find out where the sound or temperature is rising, and we do the maintenance. So that type of maintenance is called condition monitoring, and depending on the condition of the equipment, we do the condition monitoring. Like, have you seen any thermal photography of your transmission lines or electrical lines or electrical panels? So what we do? This type of image will come now when we use the thermal camera. This type of image will come, correct? So this region, red region, or this region is a high temperature region. This give indication that something may fail. So what we do? We stop the equipment and do the maintenance work. So that type of things is called condition monitoring. And one other type of maintenance is called planned preventive maintenance, in which what we do, as per the OEM guidelines, OEM means original equipment manufacturing guidelines, or as per our maintenance strategy, we used to maintain our equipment. Like OEM says that after running 500 hours, this pump need replacement of bearing, replacement of oil, replacement of other things. So what we do, when this equipment runs for 500 hours, we stop it and do the maintenance job as per the OEM specification. So that type of maintenance is called planned preventive maintenance. Because we have already planned it, that this type of maintenance should be there in the equipment. Okay, so these three type of maintenance strategies are there. Now, every process industries have different type of instrumentation, like pressure gauge, temperature gauge, vibration, flow meter, temperature transmitter, and this process safety depend on these equipments, because these shows the process parameters correctly, and if we do not calibrate it, do not maintain it, our process safety will be in the danger. Example, a pressure transmitter will be there in the system, and your parameter says that you have to maintain the pressure up to 5 kg max. But if your pressure transmitter or pressure gauge is not calibrated and it is not giving the correct pressure of the system, then your process will be in the danger. It may explode. So what will be the consequences when all these equipments are not calibrated? What will happen? Failure to meet the quality system, safety risk for employees and customers, poor product quality and loss of reputation, failure to comply with legislation, causing the loss of license to operate. So you can lose your license to operate also if you do not calibrate your this instrumentation. Unexpected downtime will increase and economic losses to the company. That's why it's very necessary or required to calibrate and maintain all this instrumentation. Okay, so any question? Again, I'm asking from this plant integrity. Life cycle maintenance strategies. Any question?
No.
Other people, have you got any question?
No, sir.
Okay. So we are not going to continue for today because already we are ahead of schedule. Okay. So I don't want to bother you much on the study front. Slowly we will go through so that you can understand what we are learning. And hope so my pace is okay. I'm not going too fast. Hello.
Yes,
Absolutely fine, sir.
is okay.
Yes, sir. Okay.
Yes, sir. It's okay.
Good. So, okay, first of all, we'll discuss about tomorrow's class. Do you want tomorrow class or you need holiday for Sunday?
Holiday, sir.
Solid.
Okay. Okay. So generally we have a holiday on Sunday. So next class will be on the Monday. Okay. Clear? To all of you?
Okay.
Clear, sir.
Okay.
Clear.
Okay.
Okay.
Okay. Next, have you got this access to Google Classroom?
No,
All
sir.
of you?
Yes, sir.
Okay. So whoever not got permission in the Google Classroom, please be in touch with your course coordinator. Ask them to give you access for the Google Classroom. Okay. And start practicing the mock tests. There are a lot of mock tests is there. You can
Okay.
try that. Okay. Also, there are many videos and case studies for your reference. So please go through that videos and case studies. Whatever we have touched till now, all are there. Chernobyl, Philadelphia, the confined space incident, all are there with detailed case studies. What went wrong, what process safety was deviated, like that. Okay, so that will give you more insight on the process safety. And practice the mock test. It's very easy to practice. And don't worry about the pass marks and wrong or right. Just practice it so that you know the essence of the PSM examinations. That will give you confidence. And remember, as I told you, remember small tips. Don't jump into the conclusion just by reading once. Read the question one time, two times, three times. Read the answers also one time, two times, three times. Then only you start clicking the answer and use the elimination method. Suppose out of 4 you are sure that 2 are not okay, eliminate it. Don't read again and again. Then only you have 2 options, 1 or 2 or 3 or 4. So decide based on your syllabus, whatever we have just discussing. Okay, so these small tips will help you. Okay, any other thing to discuss? Please feel free to ask or to share from your side.
Sir, can we get the last examination before question paper of the NIBOSH PCM?
Yes, it may be available with the course coordinator. So ask them to please provide them. Okay,
Okay, sir.
it will be available. Okay, yes, Gurjar Singh, Gurjar, Manish, anything
Yes,
from
sir.
your side?
No, sir. Actually, I have missed 1 hour class today due to some traveling. So I have joined 9:30.
9:30. Okay, so you just refer that recording. That will be good.
Okay.
Okay, Gautam, anything from your side? Gautam, Arindam, Niranjan, Vinod.
Hello.
No, sir.
Yes, yes, Imran. Anything from your side?
As you told us before in the start of your introduction that you have more than 30 years experience in different organizations.
Yes.
Can you share any rememberable accident in which you remember and your experience, past experience?
Regarding the process safety or what?
Yes, indeed, process safety.
Yeah, so very good example of a thermal plant where lubable temperature has to be maintained at a temperature of max 45 degrees centigrade. 45, okay. But one cooler was choked, the PHC cooler. That was choked due to some reason, and operators were not able to maintain the temperature of the cooling lube oil, and it shoot up to 56 or 57 degrees centigrade, and whole turbine got tripped, and the all bearings, the bearings are there in the turbines.
Yes.
You have any
Yes.
idea, Frank?
Yes,
So-
yes, I know.
So all these bearings get damaged, and the shaft also got seized just because parameter is deviated. You see the effect.
So there was no any control over the high temperature.
Controls were there, as I told you. The coolers are there. 2 coolers are there. One cooler was on standby, other was running. But due to some contamination in the water, cooling water, the temperature they can't maintain and temperature shoot up. So it's a
on the
very
high
good
temperature, on the
Ah,
high
the-
temperature, there was no on the high temperature there was no any interlock to trip the turbine.
it was got tripped, but it runs for 2-3 minutes, and 2-3 minutes is much more time to seize the bearings, because these bearings are of white metal. White metal bearing.
Yes, I know.
Yes. So you see, that's a very soft material. So 2-3 minutes is much more time to got damaged. And one more example I can give you: the boiler blast. In the thermal plant there are boilers.
Yes, boiler
In
bursting.
Yeah. So in that there is a tripping on high pressure and low pressure. Sorry, not high pressure. It's a positive and negative pressure. Positive pressure and negative pressure. Positive means pressure
Yes,
in
close to
positive side means more than atmospheric, and negative is less than atmospheric. So boiler works on these two parameters, positive and negative boiler pressure. So what happens after major overhauling, these protections were not checked and that was not commissioned after the major overhauling, and they started the boiler and pressure got positive and boiler blasts, and at that time I remember 7 to 8 people died.
Oh, too much fatality.
So this is a very good example of process safety deviations. This all comes under process safety, like we are discussing now parameters and our equipment. Just now we have touched upon the critical equipment like our gauges, any type of transmitter, gauges, or protection system. So at that boiler, our protections were bypassed and boiler explosion takes place. And we in the newspaper also many types of deviations or process parameter related incidents comes into our knowledge. Recently in US, one tank got ruptured. I think I shared this the group, and 22 people died in USA. Just remember, this is USA, not India or any Asian country. That is a very good example of process safety. Why tank got ruptured? That we will discuss in coming slides. What are the different failure of the tanks?
Okay, thank you so much.
Yeah. Okay. Any other questions from anyone, please? Ashutosh, Pawan.
No question from my side, sir.
Okay. Yes, Jala. Anything from your side?
Yes. No, sir. All okay, sir.
Okay. So, can we conclude it for day?
Yes, sir.
Okay.
Yes,
So
we can.
we will meet on Monday. Correct? All agree on this?
Yes, sir.
Okay. So thank you and good night. Happy weekend to
Good
all
night,
of you.
sir.
Thank you. Good night, sir. Happy weekend, sir.
Thanks.
Thank you, sir.